Hello, everyone, and welcome to our webinar today. We are super excited to be hosting Chris Morin, who will be driving forward today's webinar about advanced. So as you can see on our screen, Chris is our incredible leader of today's session, an educator, a writer, a content creator, an area sales leader for Mitsubishi, and a veteran. But most importantly to me, he is a conduit tech, and we're grateful to have him here today to lead today's session. So without further ado, I'm going to lead it directly over to Chris, who's going to take us through some really important topics in zoning systems.
Oh man, thanks so much for the nice introduction, Shelby. I appreciate it. So yeah, today we're going to talk about some advanced zoning concepts. And I apologize, we didn't have a nice summary slide. My slide deck was missing the picture of me when I looked a little younger with less gray hair. So hopefully everybody that's seeing this is going to be able to follow along. It is going to be fast paced, and I have a lot of information to share. So if you have questions, make sure you throw them into your chats on whatever live stream you're on. We do have Shelby and Marissa monitoring those today. And really, I'm so excited to talk about system zoning because it is often forgot about and done at the wrong part of the system design process, right? So most people in the residential field understand system concept, right? System concept is like, do I use a boiler or a furnace or an air conditioner or a heat pump, right? And I'm going to be skipping over that section because if you're watching this, I assume you know what kind of system you're going to be using. Most people follow the JSD procedure, right? So manual J for load calculation, manual S for equipment selection, and then of course duct sizing. So what you may not know is in the ACA design process, obviously the residential manuals are different than the commercial manuals. I'm going to be talking about the residential side today. And manual ZR has actually been out for about 5 years now. It was in peer review for many years previous to that. And it really applies to single family residential homes, multifamily attached houses, and of course, it could even be large multifamily buildings, right? So manual ZR, you can see it's not thin. It's not a bulletin. It's not an email. It's actually a procedure. Comes right after the load calculation. So I'm just going to flip back to show you again the process previously. Goes J, then ZR before you select equipment, right? So, but this actually is almost like a chicken and the egg thing because in order to do the load calculation correctly with software, typically, because the software is so detailed and entailed, right, takes a long time to do it, you have to know how you're going to zone the system out in order to put it in the software. So I promise at the end of my session today, Shelby's going to jump on with a couple slides to talk about how this process can be cumbersome and how technology is actually going to make it a lot quicker and easier for you. All right. So moving right along, like I said, the goal of manual ZR is really to help you design and define the requirements to design zone systems for a home, right? That's the goal. Now, that goal can be split up many ways, right? So the scope of manual ZR covers the typical zone dampers, right? That's probably the least expensive way to zone out a house. But when you start zoning out correctly in a home, typically you have multiple pieces of equipment and ideally variable speed. Now, this could be variable speed furnaces or variable speed heat pumps. It could be mini splits. And I notice I didn't say ductless because that is one way to zone with equipment. It could be a mix of ducted and ductless. It could be ducted zones on a mini split condenser, right? So there's many ways to slice and dice this house depending on the needs of the home and the expectations of the homeowners, right? Or the builders. Now, keep in mind, this does not pertain to anything that's in manual SPS. So that would be pools, spas, waterfalls, the most amazing things that you can find in new construction home these days, right? If you're adding that kind of level of moisture and control and chemicals, that's got to be addressed by a totally different system. And that manual will walk you through that. It does have to be zoned away from the regular comfort systems. So that does state that in this manual. All right, so like I talked about before, very briefly, Owner input tends to be the number one thing that influence your decision in making those zoning decisions, right? So ideally, if this is a retrofit home, an existing structure, you're going to be limited by the layout or the location of the ductwork, or access to certain pieces. You might not be able to zone out every room that you want to zone out, right? Even though the homeowner may want you to. Now, if this is a new structure, you may be working with a home builder or the owner and the builder, and you're trying to identify these needs in order to provide the highest level of comfort for that house, right? So ideally, you're going to be working with them as quick as possible, like before the first line on a design goes down on the piece of paper, right? Also, you have to keep in mind the need for like unusual equipment, right? Or the ability of the equipment in order to zone out all of these spaces. Don't worry, I'm going to get into those details in a second here. But I want you to understand there are limitations that may not be able to allow you to zone it the way the builder or the homeowner wants you to. If you're in this trade and you've designed systems in the past, you know exactly what I'm talking about. Ideally, we could have the smallest of zones in every single room. It can't happen with today's equipment right now, right? Also, you need to take into account things like unusual lighting loads. So lighting loads tends to be forgotten or impact the sensible gains in a room like a kitchen, big kitchen, a lot. And it can influence how much you need to zone that area out from the house. Or, of course, IAQ issues for health concerns. Maybe you have a son or a daughter that has asthma, or something along those lines. Or maybe you even have an elderly occupant, the in-laws, let's say, living in a section of your home. Chances are you probably will need to zone out that area because they live differently and comfort is different for them, right? So that's a couple of real high-level basic reasons you need to zone out some spaces. Let's talk about the advanced portions here. So if you don't zone out a house, and you can see this is a very simple ranch or first floor of a cape, right? You might have a central thermostat that's mounted in the center of the living room there on an interior wall, right? And unfortunately, we're going to maintain temperature wherever that thermostat's located, right? So you can see here in this construction type, that first floor suite, right? The bedroom, the bathroom, and the walk-in closet, as soon as they close that door, it's not going to be as comfortable as it will be where the central thermostat's located in the living room, let's say. So ideally, there's ways of cutting down temperature differences, and I'll talk about some of the common stuff towards the end of the presentation today. Ideally, you're putting returns in all of these rooms to cut down some of those temperature differences, but it's not always the case. And we tend to put thermostats in locations where we don't actually live sometimes, like hallways, or let's say on the near the porch exit right there out the front of that front door. It's just not a good location, but it's accessible and it's easy. So, and that's where maybe a central return goes. So that's where we put the thermostat, and we're trying to maintain temperature there, not where we're spending a third of our life in that bedroom, right? So it's really important to consider the construction style and the layout of the house, right? And to really look at remote spaces and make sure you zone those remote spaces, and particularly like architecturally isolated spaces, right? So as an idea here, you can see this is a much larger floor plan, very similar in that you have an open floor plan area for the great room, the dining room, and the kitchen. That could be one zone. It's wide open, right? But you can't put it on the same zone as the architecturally isolated spaces of the bedrooms on the left-hand side of this floor plan. That should be at least one other zone. You might find you need to break it up into multiple other zones, depending on the gains of the fenestration and stuff like that as we go here. Obviously, remote spaces, like let's say a bonus room over a garage, sure, you could add it to an existing system. You may not financially be able to zone that off, but it's never going to be as comfortable as the rest of the house if you don't, right? So remote spaces, architecturally isolated spaces, you should consider zoning, all right? Now let's get to the other stuff. Let's talk about lifestyle spaces. And obviously, the last few years after COVID, this lifestyle space in a home has changed drastically. For instance, my home office where I'm teaching this today, right? So this home office gets a lot more use with a lot more technology, and the lighting and the cameras and all the stuff you can't see under my desk when it comes to UPS backup. And it's amazing all the stuff that throws off heat that wasn't here 3 years ago. So this is an office, a home office. If I was walking around my house today, I would consider zoning off that home office so I can be comfortable in this space when I'm working here, hopefully just 8 hours a day. But you know how that goes, right? When you're at home, it's easy to start early and end late. So maybe you have entertainment rooms or a hobby or a game room, right? The needs in this space is significantly different than the rest of the home for comfort. So you're going to have to zone for lifestyle in that instance, right? And it's possible that what you consider a bedroom in a home for listing purposes on realtor.com or whatever, right, may not be what the homeowner is using it for, and they may never be comfortable if we don't zone that off, okay? And that could be, like I talked about before, in-law suite or something. May not be the case in every home. You may not have to zone that off based on the way they're living. But if you want the new homeowner to be comfortable, it's their opportunity to address that problem, particularly when you're replacing a system, right? This is what we're talking about. You do the load calc. Now we have to address how we're going to zone it out before we select all of the equipment for it, right? Manual ZR comes before equipment selection. All right. So enough beating on that. Those are some obvious things to zone out. Now let's talk about what usually happens out there and where we should consider zoning more. So most of the time when you have multi-level homes, let's say a colonial home, we see that a lot here in New England. Everybody understands when you're heating a colonial style home, you can't have one zone. Most of the time you put the thermostat on the first floor. And I'm going to hate to say, you're going to see a picture of my house later. And my house was built in 1880. It's a Victorian. I have one thermostat on the first floor for my single pipe steam system. So it does overheat the second floor where my home office is, particularly with all the other gains in my office, right? And we know this intuitively because of temperature stratification, right? We understand if it's a single zone for multiple level homes, we're not going to be able to keep that temperature within 3 degrees across those floors or rooms. And if you didn't know, when you design for comfort, which is manual RS, that's the level of what we feel is obtainable and acceptable in the trade, within 3 degrees across rooms and floors. Obviously, if you have multiple levels and there's anything below grade rooms and areas should be its own zone as well. Now, if you have some open areas, there's a lot of newer construction like this, that when you walk in that first floor, that front door, there might be this huge vaulted ceiling, or it's open to the second floor. And in order to cut down temperature differences, if you don't zone, I see a lot of people put in ceiling fans to force that hot air back down to mix in the room. Keep in mind that does drive up electrical use, but it could be more comfortable in the space if you're trying to address situations where you weren't able to zone this house out during construction or something like that. And you now, even though you're zoned by level, you have to consider peak fenestration loads, which would be what the sun does to those windows, right? So ceiling fans can help in the heating season, but it's really hard to help in the cooling season. The only way to remove moisture in the cooling season is to bring all that air back for a return and run it across your A coil, right? Or your coil in a ductless system. If you can't get the air to pass across that coil, you can't remove the latent capacity of that home, right? So ideally, returns in every room help, and keeping the airflow moving helps, but that drives up costs, right? Ceiling fans can help across those levels, but you may find, instead of just zoning by level, if you have a lot of glass facing east or west or south, you might have to split that up into more zones. You shouldn't probably do it the way it's sliced on the picture here. This is to bring up the fact, instead of 2 zones, upstairs, downstairs, maybe you need 3 or 4 because of the way that glass faces and the peak fenestration loads that you're going to find on an AED curve. I'm going to show you in a second here. All right. So this might show you that with all of that glass facing west, I need to group those upstairs west-facing rooms in one zone, and I have to have 3 zones in the house or more. Okay. All right, moving right along. Zoning incomplete construction. So if you're adding a new addition to an existing building, the codes have changed most likely since that building was built 20, 30, 50 years ago. In my case, 140 years ago, right? So if I was to add an addition, the new addition is going to have a much better window, a much higher insulation value. It's going to be much tighter, weatherization, right? And that area is going to perform differently than the rest of my house. And I will never be as comfortable across those spaces if I don't zone that out. And this is why you can't just add a boiler loop to an existing boiler or run a duct run over to your bonus room in the garage that you just refinished, because it doesn't match the construction type of the rest of the house, right? So upgrades to the existing home would have to be recommended, and typically are, if you want to run that as one zone. If you're going to zone it out, you're going to be much more comfortable, and you can maintain that plus or minus 3 degrees that we talked about earlier. All right, moving right along. The best way to consider which rooms to zone together is using what Manual ZR outlines as cooling heating ratios. Now, in order to do this, you have to do a room by room load calculation. You have to select the equipment because you need to know volume of air. And then you also need to run through the duct sizing worksheet, which is built into some software, in order to find out what the heating and cooling CFM needs are. You'll notice on the duct sizing worksheet out of Manual D, it's the 3rd and 4th columns here. They are going to be different. Even if you run the same airflow and a heat pump in cooling and heating, the needs for that room in cooling and heating for airflow purposes are different. We typically design around the higher of the two. And that creates the problem, because we're going to have excess air when one zone turns on, right? That excess air is going to leak into other rooms. Now, if you only zone upstairs, downstairs, and where the thermostat is needs heat, you might overheat, or in cooling, overcool other rooms. And this same process and issue applies to multi-zone heat pumps as well, right? Where you have multiple wall mount systems off of one condenser. And when you don't zone them correctly, and when we zone with that type of system, we're zoning with a condenser, and we should put the rooms that are compatible together. And anything, when you divide your cooling CFM by your heating CFM, you should group that ratio. If it's less than 1, those rooms go together. If the ratio is more than 1, those rooms go together. Keep in mind, we still have that floor issue as well, okay? So this is really important in identifying the compatible rooms to put them on the same piece of equipment or the same zone when we talk about duct systems, okay? Now, we have to be able to include that excess supply air, and this is the way to do it, right? Because we're putting those compatible zones, those compatible rooms together in one space. And by doing that, we're not going to overheat and overcool the spaces that are not compatible. If you find that the airflow needs are within 15% of each other, then you're going to be able to maintain that 3 degree plus or minus, and you're not going to have comfort concerns or problems. What you have to look for is large fenestration spikes, and we find this on the AED graph that's provided with Manual J version 8 software like Conduit Tech, right? So you're going to find if that AED curve spikes above the average of 1.3, so 30% over 100%, 1.3, then you should zone that home. And this is where we can typically, if you do a room by room AED curve, you can see when they would actually spike. And in cooling, I have to group those rooms together. But what if you heat and cool with the same system? We're forgetting about that other side. And that's why we tend to overheat those spaces if we don't zone correctly, okay? Obviously, you have to make sure you're going to put the thermostat into a living area, right? Not just a hallway. I see this all the time, and we'll talk about things that you don't do in a second here. I'll reiterate this. But if you have a central return in a hallway, and that's where you put the thermostat, we don't live in the hallway. So we got to stop doing that, right? And in order to improve temperature control, we have to put it in the space that we're going to spend the most time in that zone, right? So that might be the master bedroom. That could be the living room. It could be something I haven't thought of. It could be my office, right? I might want this to be the spot. Maybe I group this and my daughter's music room and another room together because they have the same needs and the same ratio. But I'm going to put the thermostat in this room because this is where I spend the most time out of that zone. Hopefully that makes sense. All right. Obviously, the larger the home, the more zoning needs you're going to need because you're going to have windows that face different areas. You're going to have different uses of rooms, right? And really, fenestration is one of the most challenging things here, okay? And of course, if you have multi-levels or you have a rambling house that's all broken up, then you're going to have to look at, first off, getting the ductwork right if you're doing ducted, and then how to zone all of those rooms. Now, this is a picture of my house. I'm fortunate to own a very historical home. It leaks like a sieve, and it has a very old heating system that I've done the best I could with. I'm one of those historical guys. Like I like old watches, and I like old homes and that sort of thing. Just keep in mind, you pay for that vintage look. It's expensive, even if it's just your heating bill, okay? Eventually, we'll have something nice and new in here. I think everybody knows my day job. I work at a manufacturer. I'm sure one day we'll get there, but we have a lot of other structural things to do first, okay? So you won't see any pictures of condensers outside in this example. So a couple of zoning rules, and this is things you shouldn't drift from. And it's really easy to drift from these in the sales process because you want to say yes to the homeowner. And usually it's just about costs. But if you say yes too much and your equipment can't do it, then you shouldn't install a callback. You shouldn't lose money on these jobs, all right? So obviously, number one, like we talked about, zone each level, all right? That's really important because of stratification of air. We know this is the buoyancy of air, but I won't get into the properties of air. It's not really what's going on, okay? Obviously, you want to look at the floor plan and zone because of architecturally isolated areas or certain floor plan attributes. We have to also take into account lifestyle and occupant desires, right? So how the homeowner or how the builder plans on this home being used. And then always look at bonus rooms. This could be that room over the garage. This could be a bump out. That's a sunroom. That's going to be 4 seasons. This could be a basement that's refinished, right? We changed the regular use of that space. And now it should be zoned because it's not compatible with the rest of the home, right? So that's some basic zoning rules. Next, you have to actually consider, please, the manufacturer equipment capabilities. So a great example of this would be, I want to zone in every room, and I have a 5-room ranch. I can't just put a wall mount in every room and put in that size outdoor unit for a multi-zone heat pump, right? It's just not the way it works, because when you add up all of the smallest possible indoor units, the outdoor unit is going to be drastically oversized in one season or both. So we have to consider the equipment capabilities, how far they can ramp down, and really make sure that we're going to provide comfort, because by zoning the home, that's the whole point. We're going to provide comfort, not equipment failures and high electric bills and uncomfort space, right? Also, anytime you think that you could actually run heating and cooling at the same time in a home, you should zone that out with equipment, or make sure your equipment has that capability. There is a lot of residential equipment that cannot run heating and cooling simultaneously. Also, like we talked about before, anything in manual SPS, like swimming pools, spas. I've seen some crazy stuff out there. It's beautiful in the home, but that needs a dehumidifier and a different way of providing comfort for that space compared to the rest of the house. You can't put that off of the regular system, okay? So basic zoning rules. We'll talk about thermostats. This should be very brief. Ideally, no one's putting in a T87 anymore. Whenever I talk about thermostats, I still have this habit of doing this. Those mercury thermostats are long gone. But when you install one, typically it's 5 feet off the floor, right? Unless you're in a handicap capable situation, that's probably going to be a little lower. And you need to put that in the space like we talked about, where you actually occupy the space, not just in a hallway near a return, in the room of that zone that you occupy the most. So you're going to be the most comfortable all the time, Okay. Some things not to do. Now, this could be common sense for most of you, but if you're new to the trade or you don't have a technical background or service background, you may not have run across this. You might not understand. And we don't want to promise the homeowner things that can't be done, right? So we don't want to put a thermostat in direct sunlight. That seems obvious. There's less problems now with electronic thermostats, but there are sensors in there that could artificially drive up and we won't have a comfortable space elsewhere. Obviously, we don't want to put a thermostat above any sort of heat source. So we see a lot of dual fuel systems go into home now, where you might have an existing oil boiler, let's say, or a gas boiler, and then you put a heat pump in order to offset that fossil fuel usage, right? It's a big part of rebate programs in New England, as well as elsewhere in the country, okay? If you do this, you don't want to put whatever's sensing temperature above that baseboard, because obviously we're going to sense a false temperature in the wintertime, and it's going to shut that heat pump off. If it's going to cause conflicts, right? Or above a floor mounted heat pump, let's say. All right. So really important, or supply registers, right? This seems obvious to those that have installed systems, but if you're out there selling and you haven't done this, you got to stay away from these areas. You never obviously put it behind doors, in corners, or dead airspace. Now, this is really important. If you've never read Manual T, it's terminal selection. If you remember way back at the beginning of this presentation, there was one slide on all the design manuals. Guess what's next after ZR? It's Manual T with Manual S, right? You have to actually select the equipment based on the needs and locations and how you're going to run that ductwork. You do this before Manual D. You have to have a great idea of the equivalent length of all those fittings in order to get the air from A to B, right? And if you're going to put supplies around or you're going to stick thermostats in dead spaces, they obviously walk through stratification of air in Manual T. Highly recommend you read it, all right? Don't put thermostats in those spots. And obviously stay away from an exposed wall. Or unconditioned spaces, like on the other side of the wall, there might be a garage or something along those lines. Don't put a thermostat on that wall. It's on the back of that wall. It's going to heat up or cool off, and it's going to give you a false reading, okay? So always on an interior wall. So basic stuff here, but don't do that with zone thermostats. All right, let's talk about some equipment issues. The more we zone a home or spaces, the smaller the zones need to be, right? And that's when I talk about the equipment capabilities and understanding if the furnace can ramp down that far for that volume of air, right? The more you zone off one condenser or one furnace or one system, the less likely it's going to be able to perform under lighter loads, right? Because we're sizing the system typically for the 99 or 1% design temperatures. So what happens when we're, instead of here in New England, my design temperature is about 5 degrees. What happens when it's 40 degrees and we still need to heat the space? It's drastically oversized for that one zone, if we continue to zone and slice that up, and it can't ramp down that far, right? So we have to consider the equipment capability. Obviously, we have to address in the initial plan what the method of zoning is going to be. And we don't want to divert heavily from that. So as an example, we might use the CH ratio. And then all of a sudden, somebody changes the use of a bedroom way down in the construction. Instead of just moving that off to some other part of that same system, we should actually consider, okay, you want to make that bedroom a home office, it needs its own zone. Don't redesign everything else you've already done in the house because of a change in the zoning method or the plan, okay? Obviously, costs is one of the biggest limiting factors. The more you zone a home, whether it's with dampers or equipment or wall mounts or floor mounts or ducted systems, the more likely the homeowner is going to gasp when you give them the price, right? So it's really hard to then value engineer that and still deliver the comfort they expect. They still expect to be comfortable in every room, regardless of what you tell them the cost is, right? So if you are able to provide a different solution and a different zoning plan, you have to let them know, well, we're not going to be within 3 degrees in this room unless we zone that room out, like my home office here, okay? And then, of course, you need them to agree to those zoning compromises, right? So make sure you write it down. How many times I wish I would have done that in the past. All right. Sorry. You know how that goes. You learn by you learn the hard way once, right? That's the whole point of this. Hopefully I learned the hard way for you. All right. So minimal zoning, if you're not able to zone, you should consider just some very basic things. Let's say you can only do 2 zones. Cost is very low. How are we going to try to make this the most comfortable? You'll see a floor plan here for the first and second floor of my house. Maybe we zone the living areas together and all of the sleeping areas together. And that's typically first and second floor, or like a ranch I showed you before, left and right side of that ranch, right? Keep in mind that there are some comfort issues when you talk about setback and how that operates. If there's a lot of zones, like let's say all of the sleeping zones, you want to set back at night because the customer likes to sleep cooler in that zone. Ideally, we'd like to zone that off with a different piece of equipment because we don't want the whole home heating back up when it's morning and you wake up and now you want it, I don't know, 70 degrees downstairs while you're cooking breakfast, right, on Saturday. So by zoning out with equipment, it actually could be much more efficient for the home and more comfortable for the home in that instance. You know, retrofitting a duct system to a constant volume furnace or air conditioner is probably the least effective way to zone out a house, but it's probably also the least expensive way to do it. So it is possible, particularly with more open floor plans and stuff, to do it this way. But you tend to burn a lot more electricity or a lot more gas, and you're going to run across these comfort problems because a lot of times you have just one large trunk or 2 large trunks that you're actually going to zone off, and you have incompatible rooms, like we talked about at the beginning of the presentation, off of that same trunk. And we tend to overheat or overcool some of those rooms in order to provide the higher level of comfort for floors, let's say. Ideally, we're zoning with equipment in that instance. All right, I'll stop beating that horse. Next, we're going to zone for efficiency. So if we start looking at seldomly used zones or rooms in a large home, we could zone those together. Now, this comes up a lot with like empty nesters or a large home like here, like where I live in this old house. I have a playroom and a music room, like I talked about earlier, right? And a bedroom that we turned into that like entertainment area where I can shoot baskets and stuff with those types of game room stuff. It's fun. I very rarely get up there though. And that's why I should zone it off for efficiency, right? I don't want to heat all of that space upstairs where my in-laws used to live. They have since moved out. And I don't need to, right? So why would I heat and cool that space when I'm not living up there and I go up there maybe once every couple of weeks, right? To do something with my daughter or something, right? So also huge setback or setup periods would zone for efficiency like we talked about earlier. And then of course, personal experience, right? So interviewing the homeowner and understanding where those hot and cold spaces are that they are living in now that maybe they weren't when the system went in, or maybe the previous homeowner had not zoned off and it's a different living space now. So zoning for efficiency is really where those mini split heat pumps really came into the market fast to address these hot and cold spots. And now it's really taken the Northeast and the West, even parts of the South by storm, right? It's becoming a big part of what a residential HVAC contractor does every day. And if you're not zoning it correctly based on all of these needs, you can see how things can get away from you very easily. And it takes time and understanding and software in order to make that happen, right? All right. Now, there are a couple of alternate or options for zoning, right? So ideally, like an open floor plan, you don't have to zone off like we talked about, right? You could take the perpetual shade route, right? So this could be trees that are around your home that obviously in the summertime might have leaves. In the winter time, that might drop. So that way you pick up a bunch of heat in that space. And that's how my house was designed until a builder separated the land and built some homes over there and took down all my trees that face south and west. So now I have to worry about using shades, right? In order to cut down those new gains that weren't there how I was living 8 years ago, okay? So there are things that change. Also, too, You can find that if you're unable to zone certain areas that have, let's say, skylights, a better option, instead of trying to zone that because it doesn't meet the homeowner's budget, maybe to get the homeowner to put shades on those skylights. That could drastically drop the gains, and it's more compatible with those other rooms now. Now, one other option I see a lot of technicians do is just turn the fan on for continuous blower. So this might work okay in heating because you're going to mix the air better, but you have to consider a lot of other things with the system. Maybe there's ventilation attached, and now you're going to introduce a lot of cold air in the wintertime. Or in the summertime, you're going to introduce a lot of moisture into the home. And because you're not going to shut the fan off, there's no way for all that moisture in a climate like Miami or Boston or Baltimore, right, on the East Coast, or anywhere along the coast, right, all the way around the United States where we have moisture problems. And that's why we put air conditioning in order to get that moisture to drain off the coil. If we don't shut the fan off, all that moisture starts to evaporate back into the air, and it drives the humidity up. And what you think you're doing by turning the fan on to cut down temperature differences across rooms makes it worse, because now we can't remove the moisture in those instances. And it increases the kWh and the usage of the home. So that's an afterthought and a Band-Aid to the real problem. Make sure you address those real problems. If the system's already installed as a technician, maybe it's offering zoning or offering a single zone ductless system, or addressing which rooms are on a certain zone. Maybe you can modify the existing ductwork and the existing damper system. There's a lot of products out there that can help you do this. But to do it right, it all starts with a load calculation that's room by room, and finding out what rooms are compatible in that manual D process. So I taught this pretty quick. I'm actually going to turn this over to Shelby, who's going to talk about the technology that's available to help you. Shelby?
Thank you so much, Chris. I'll be brief because I want to get us to Q&A. But ultimately, this has been so helpful to sort of identify the need for a load calculation to estimate as the very starting point what you're going to need on a room-by-room level. And there are 3 ways to do that. So there is the traditional pen and paper method. If you want to check that out, make sure you check out our prior with Chris, where he walks through some of the load calc theory and the work behind that. There's traditional software platforms that require detailed analyses and documentation that require a lot of information about the building, and you have to go out and measure it for you. And then the third, of course, is where we come in. This is what we're starting to build, which is newer technology. Our platform, as you'll see on the next page, is leveraging LiDAR to be able to create load calculations, 2D floor plans, and 3D models in about 50, all integrated into sales materials and documentation for the install team. And our main objective is, this is a lot of work. This is the foundation to be able to create a system for your customers and be able to do the zoning work that Chris is outlining here. And our goal is to help you stand out while you're doing it and use tech in a way that makes sense for you. So with that, that is just a little bit about us. But I'm going to get back to that you all came to get answered. So we will stop sharing our screen. I'll remove perfect. And the first had come in through the chat is, what is your opinion of smart vents and registers that open and close based on temperature in that room? Oh, I'm so excited.
Oh man, I hope that got, I feel bad because I know some of these salespeople. So I'm in sales myself. Smart vents, anytime you're shutting off or balancing airflow at the register, it's extremely noisy and extremely inefficient. We shouldn't design a system to modify the airflow at the room after the fact, because it increases static pressure, it increases electrical usage, it increases the temperature of the ductwork, right? So in a gas furnace, we might start short cycling because we decrease the volume of air. In some instances, there's a lot of things that impact when we just start turning down the airflow at certain rooms. And this is why, the thought way back with constant volume systems or a single speed system was, when my kid goes to college, I shut the register off in the space. That could make a system run drastically more inefficient if it wasn't designed for that, which I'm willing to bet it wasn't. Anytime you design a system that you want to balance out for actual airflow to a space, you want to put a damper in the ductwork as close to the trunk as possible to reduce noise and to balance the system out for the right volume of air going to that space. Another whole manual, but I hate to say it, 100% do not like that product because of that reason. Now, there are reasons people have to put it in. It's a less expensive solution to address one particular problem, but it's a Band-Aid, unfortunately. So sorry, guys, if you're on the line. I hope it wasn't you guys. Ooh, I do see a question. So Shelby typed it in. It looks like Alex typed in, Chris, can you speak to optimal approaches for zoning with inverters and how different inverter types respond to zoning? So refrigerant pressure-based inverters versus fully communicating inverters. And what equipment is necessary to do it properly? So that's a great question. So I can't speak across all manufacturers. I do have some experience with very many. Obviously, I was a service manager years ago when some of these products first came out, right? They've come a long way. Most of the time when you're using inverter technology, you want a zoning system that's compatible, that can speak to the controls, the native controls, that can give you the best efficiency. So as an example, and I'm just going to pull a manufacturer out of the hat here, like Bryant, let's say. So if you're using a Bryant variable speed furnace and air conditioner, you want to try to get a Bryant zoning system that's going to work and communicate with that, because it's going to, when one or two dampers or whatever, however many dampers turn on, it communicates to the furnace to say, this is what we should run at. And then the furnace runs at that. If we try to use a third party that cannot communicate, so the basic open close dampers, that's where we start running into problems, and we start putting in things like bypass ducts and ways of addressing the higher static pressure and the inefficiency of doing that. And then it becomes a race, right? When we start running bypass air across a furnace, does it reach temperature in the space or does it short cycle first? Okay. So yeah. So refrigerant pressure based inverters, basically what they're doing is you're maintaining a certain temperature in the coil. And when a zone opens, we can move more volume of air. When a zone closes, we need to decrease the volume of air to maintain the same temperature in that coil. So then it'll communicate out to that heat pump, let's say outside, to ramp the compressor down or ramp the compressor up. Okay. So a little bit technical there. Obviously, it does impact how you zone. And really the main thing here is you want to look at the minimum, the turn down. If we're going to operate, or the needs for those zones are higher than what it can turn down to, then we're probably okay. But if it's the opposite, especially under light loads, and we're just going to short cycle the compressor or the furnace all the time because the needs are less than that, then that's when we start having mechanical issues and inefficiency problems and comfort problems. Sorry, went a little long-winded there. All right, next one came up. Thanks, Shelby. I think Shelby's typing this in, or it's Marissa, one of the other. I appreciate your assistance here. How much time should a practitioner allocate for coming up with a zoning strategy before doing a load calc or other parts of the system design? All right, so this is an art, and this goes to how you're going to question the homeowner and pull that information out. So hopefully you have a good site survey process and comfort design process. And you have to do this at the house, right? So, you're not going to be able to come up with a zoning plan without talking to the homeowner or visiting the home or looking at a set of plans, right? And honestly, your software that you're doing your load calculation with is going to take way more time than how you consider to do this. And if your software doesn't allow for easy changing of zones, like and not to make this a product pitch here, but I've used Conduit Tech. Obviously, I'm an advisor there. It's really easy for me to click on a bunch of walls and make that one big room. That's one zone. I can see the needs for each zone. I don't have to go back and do the load calc all over again. Now, if I was using worksheet style software, I would have to start to re-enter all these different things if the zones change, and it drives the time up. Ideally, once you understand how to use software and using something quick, like say Conduit Tech, I could probably do this sort of zoning and load calc and everything I need in my home in 30 minutes to an hour max. But to give you an idea, it would take me with the software that you draw out a floor plan on, I won't use names, It would take me an hour to an hour and a half to do that correctly for my house. It's kind of large and it's all separated, right? It's a Victorian home. With Conduit Tech, it took me 15 minutes. So because of that time savings, I can actually spend more time talking to who, in this case, would be my wife. She's making the decisions at home, right? So I'd be able to talk to the homeowner and spend more time on addressing those comfort needs where I maybe couldn't because of the software I was using to get the load calc done in the first place. So a little bit of an answer there. Personally, you should get that all done in an hour. I don't know how you could spend enough time to build rapport and sell solutions on that first call if you can't get a load calc and zone layout done in an hour.
Amazing. Super helpful, Chris. Well, those were all of our questions that came in. Want to thank you so much for joining in today and sharing so many insights with the audience. And just thank you everyone who dialed in today to learn a little bit more about this. We'll be making this available as well. Rewatch pieces of it. Just don't hesitate to reach out. So thank you everyone and have a great rest of your Wednesday.
Thanks, Shelby. Thanks, Conduit Tech team.